All right, we're going to finish off the unit on systems of equations by dealing with a beast of a problem. We're going to have a system of equations in 3 variables. Whoa. So now we have 3 equations and 3 variables, an x, a y, and a z, and we're going to have to figure out how to do that. So we have to put on our thinking caps. Now, if you remember from a system of equations in 2 variables, so if you remember in 2 variables, the whole goal was the question, can we work with 1 variable? So if you remember that from the notes, when we had 2 variables, can we work with 1 variable? And the way we would do that is either through substitution, where we were looking to isolate a variable, or we could work with elimination, where we were going to cancel a variable. Okay, and that's when we were dealing with 2 variables. So there's a notice. Can we work with 1 variable? Substitution, isolate a variable. Elimination, cancel a variable. So now, now we're dealing with a system in 3 variables. So let me give you really the only note. 3 variables. If we have 3 variables, the question now is, can we make 2 equations with the same 2 variables? That's an important thing. Same 2 variables. Can we make 2 equations with the same 2 variables? And if we can do that, we can find out what those 2 variables are by using substitution and elimination, and then we can find the 3rd variable, and you'll see that that'll make itself clear if you've paid any attention at all to any of the prior videos in here in this unit. So we have a system in 3 variables. Can we make 2 equations with the same 2 variables, and then go from there? You'll see what to do. It will totally be revealed. So we have our crazy looking system. We've got 3 crazy looking equations, 3 variables. What is going on? So our first equation, 3x plus y minus 2z equals 22. Please pay attention to the difference between my z's and my 2's. My z's have a line through it, my 2's do not. Then we have x plus 5y plus z equals 4. And then finally x equals negative 3z. So we have our system of equations. And again, the question is, can we make 2 equations with 2 variables? Well, what's funny is that in this system, I already give you what x is, right? And what is x? X is 3z. So what could we do with that value for x? We could substitute it into both. Whoa. We can substitute it into both of the other 2 equations. And if we do that, we would have 2 equations that deal with z now and y, and z and y. Okay, so we would be able to work with 2 equations with the same 2 variables, z and y. Because remember, that's the note, that's the goal. Can we work with 2 equations with the same 2 variables? So we would substitute first, and then we would have our 2 equations. That's the hard part, right? Once you've identified that, well, we're home free. So now that I know what x is, negative 3z, I can rewrite my first 2 equations. My x is negative 3z. Everything else stays the same. That's my first equation now. And then I would have my second equation, x plus 5y. But there's no longer x, it's negative 3z. And that's equal to 4. And so I have my first 2 equations that are completely rewritten in the same 2 variables. They're both in y and z. All I need to do now is simplify them both. Okay, so we have to simplify the whole thing. So we're going to simplify the whole thing. So the top equation after we simplify, we're going to get negative 9z plus y minus 2z equals 22. And that, of course, can still be simplified. Okay, so we can still simplify that, and I'll write this one in blue. Negative 9z minus 2z is negative 11z. We can combine like terms. So we have our top equation is actually this. Okay, this is our top equation. Maybe what we call equation 1 is right there. What about the second equation? Okay, so now we're going to simplify the second equation. Negative 3z plus 5y plus z is equal to 4. And I'll write this one in red, and we can simplify this. Okay, so we have negative 3z plus z. That's negative 2z. And then 5y, and that's equal to 4. And we can call that equation 2. And guess what we have? Two equations with the same two variables, and we're basically home free. So let's take these two equations and rewrite them as a separate system, right? Equation 1 and equation 2. And now it's back to what we've done in the previous videos. We can solve this by substitution. Okay, so remember our previous material. When we had system of equations in two variables, could we work with just one? We could substitute by isolating a variable, or we can eliminate by canceling a variable. From this point, it really doesn't matter what you're choosing to do. You can solve for y and then do substitution, or you can manipulate equations and eliminate. And what I'm going to do, I'm going to choose elimination. Okay, so I'm going to choose elimination. So I will eliminate. And I'm going to choose to eliminate the variable y. I'm going to multiply the top equation by 5 because that's the hard part. Thinking of that, I'm going to multiply the top equation by 5 and cancel the y's by subtraction. So that's what I'm going to do. I'm going to multiply the top equation by 5 and subtract to cancel y. Now there's a way I can avoid subtraction. Again, you could use substitution, or you could do some other things, but I'm going to choose to subtract. Remember, when you can avoid it, do so. So I'm going to multiply the top equation now. When I multiply the top equation by 5, I get negative 55z plus 5y is equal to 110. Okay, so 5 times 22 is 110. The second equation stays the same. Negative 2z plus 5y is equal to 4. And that is my system that I'm now going to subtract to cancel y. So I'm going to subtract these two equations to cancel y. And here's where we have to be careful. Remember, we're not too good at subtracting, so you've got to be careful. Follow the pen. Negative 55z minus negative 2z. Okay, negative 55 minus negative 2 is actually negative 53. So I'd have negative 53z. And then 5y minus 5y, that cancels just as we wanted. And then 110 minus 4. 110 minus 4 is 106. And now to solve for z, we're home free. Divide both sides by negative 53. Don't be scared, because this is working out pretty well. Z is going to be equal to negative 2. And once we know what z is, we can plug it back into one of these in order to find out what y is. Okay, so we're going to plug it back in to find out what y is. I'll use the second equation. Why not? Okay, so I'm going to use negative 2z plus 5y is equal to 4, but I'm going to substitute what I just found for z, being negative 2. Now, it's easy to get lost in this whole process, so you want to be neat with your work and be careful. Negative 2 times negative 2 is positive 4. And then when I subtract 4 from both sides, I get 5y equals to 0, or y is equal to 0. So I have found z. Well, you may want to see that, right? I have found z I have plugged z back into the second equation that I made. Okay, plug it back into the second equation I made, and now I have found y. So far I have found y, I have found z. What am I missing? Go back. What am I missing? I'm missing x. So it's the only thing I haven't found. This has an x, this has an x, this has an x. It's the only thing I haven't found. And hopefully you can see there's going to be an easy way to finish this. Remember, like I said, once you get started and once you unlock, you come up with the hard part, right? You create two equations and two variables. Everything starts unwrapping. So far we have found z is equal to -2, and we have found y is equal to 0. Well, what do we do to find x? We can plug back in. We can plug it in here. We can plug it in here. I'm going to plug it in down here because I don't have to deal with a y, right? So how easy is that? So I'm going to plug it in down here. Okay, so I have my y is equal to 0. So I'm going to, or my z is equal to -2. I'm going to plug in z here and find x. So I have x equals -3z, but I know that z is equal to -2. And then I have x equals +6. Okay, x equals +6. Are we done yet? Well, no. Remember, we have to check our answers. So let's check them into each equation. You're going to find out this is actually kind of simple. 3 times x, 3 times 6 is 18, plus y plus 0, minus 2 times z, minus 2 times -2. That's plus 4. Does that equal 22? Check. So it works in the first one. Down here we have x, but we know what x is. X is 6, plus 5 times y, plus 5 times 0, plus 0, plus z. Z is -2, so that's -2. Does that equal 4? Does 6 minus 2 equal 4? Check. And then last, we have x, but x is 6. Is equal to -3 times z. But -3 times z, z is -2, is +6. Check. So all three variables work for all three equations, and we know we're right. But instead of writing an ordered pair, now we have to write something called an ordered triple. And so that'll be the last note. Ordered triple deals with three-dimensional space, and there's a lot of crazy fun stuff that goes on. And the way an ordered triple goes, if you haven't guessed already, x, y, and z. So that makes life a lot easier. So our ordered triple, our x coordinate is 6, our y coordinate is 0, our z coordinate is -2. Everything has checked out. There is our ordered triple. And that is how we deal with systems of equations in 3 variables. So in review, what's the note? The note is this. If you have 3 variables, can you make 2 equations with the same 2 variables? And if you can, we're going back to what we've done earlier in the unit, and then being able to unwrap everything. So I hope that's helpful, and look forward to practicing with you. Thank you very much.